שוב סורי, אבל...
License. Can you please help me here? Good morning.
He goes.
Good morning.
עוד פעם אתה משהו?
אני רוצה אחי לשבת מקדימה. פעם ראשונה אני בא לתרגול, תן לי לשבת מקדימה, ליד מקסים.
פעם ראשונה?
כן אחי, פעם ראשונה אני בא לתרגול. תודה אחרונה. מה קורה? לא בסדר, כן?
עייפים.
דברי חיבורים. וואו, תן, ככה אתה לוקח יוזמה. תחזק את הלוח, וואו, באמת.
האינסטגרם שלך.
מה האינסטגרם שלי? בוא נכתוב על הלוח.
תגיד תודה לפה הרבה?
לא.
איזה באסה?
אני אוהב את 221.
אז אני אבוא לשם יותר.
יאללה.
301 אני לא אוהב.
למה?
לא היינו שם כל הסמסטר.
היינו.
בתרגול של ממפיס. אתה פשוט לא פה
אני
ב-50.
לא בא.
אבל למה? אחלה כיתה, דווקא 301 אני אוהב.
זה צמוד כזה מדי.
לא יודע.
צפוף.
לא, אני אוהב דווקא.
מה זה יפה הטלוויזיה? וואו.
אני אוהב את כל השלוש כיתות האלה, אני לא אוהב את כל שאר הכיתות שמחרטטים לך. פתאום 105.
כן, הכיתות שם.
נוראי.
הכיתות שם שהיה לנו ליניארית שם, וואו אחי. נכון, היה לנו...
נוראי, זה לא...
נוראי אחי.
זה כיתות כלליות.
יש תמונות, בן. אחי, יש תמונות, אחי, יש...
מה הייתה עם מה כל הסמסטר שם? פשוט אף אחד לא שם לב.
תשמע, זה יפה. הנה, מסגרת גם.
שולק, תראה את הדוקו עכשיו על איינשטיין.
איינשטיין אין בפאום.
אני רוצה לראות את הקרן טרור, אחי.
אין את זה, יש את זה באמזון. אם יש לך אמזון? יש לך
אחי, יש טלגרם, אחי, טלגרם, אחי, יש הכל, אחי. טלגרם, אתה אמרתי לך, אחי, אתה יכול לסחור בזהב.
שאלה מה הוא עושה עכשיו?
אתה יכול לסחור בזהב בטלגרם.
איזה זה הוא עושה?
הוא יעשה לך תנע, אחי.
אבל מה, אין תרגול ב...
אולי יחזור למבחן.
יש סאבמישן אקסרסייז.
אבל מתי?
6 days.
בואי נבקש ממנו יותר. בעצם 6 days זה סבבה.
איזה עייפות.
כן, כן.
לא מופיע.
יש את זה.
איפה?
התחלנו את זה פעם קודמת. התחלנו אנגולר.
אנגלה. או, יהיה. איזה מטוס.
מקסימום אולי תפרוץ לו עוד פעם. מקסימום פרץ לו לחשבון.
באמת?
כן.
מקסימה האקר.
בקיצור צריך להכריח על אלקטרונית, אחי, לנסה להשיג דוח.
על?
על מה שעשינו אתמול, אחי, טרנזיסטור.
אבל יש את התרגול
הטלוויזיה כאן לא פועלת, אבל כל שעות פועל כאילו.
אוקיי.
זה הכוכב שנאמרנו לו בתרגול הטלוויזיה הזאת. מה הוא יעשה? אתה רוצה אני עומד יחזיק את הדפים של התרגול ככה? מה זה בעיגול?
לא, יש אדם פה למטה, פשוט.
לא, שכולם יראו כאן.
יש את התרגול במודל?
כן.
זה 10?
וצריך להתחיל את ההקלטה כשאתה...
סבבה. זה איפה מסבל, נכון?
איזה איחור. יש לך עוד זה.
רואה טוב, לא שמנו. סלח לי.
So last week I uploaded homework and I forgot to upload the option of submitting them. As you all noticed. And not sent. Did not say anything. I was forced to give you more time for it. Why is it not working? Did you ask someone?
Yeah.
And what did someone say?
They will tell the issue to another one, to another person, and they will fix it.
You blame someone else.
Eventually, but they don't work.
Okay. Do you like this thing in general? That everybody teaches also here?
Yeah.
I like it's a good concept, right?
Yeah.
Okay. So, today, I just had the recording. Man is recording. Stop recording. Stop. ברוכים הבאים. Welcome. To our last room. Did someone just join?
That's the recording.
Oh. Welcome to our last class. Today we will learn about angular momentum. We started learning about it last week, but we'll continue today. Two background things. Let's start with some background. One thing is that we had A and A Degel, which were very weird operators. They did not represent any physical meaning, but they were super useful, and doing anything was way easier using them than not. Second thing is that at the end of last week, I spoke about more dimensions. And I started saying that when you have something two-dimensional, so you can have nivun, degeneracy. You can have degeneracy, meaning you can have a few states that have the same energy. I presented it in an infinite two-dimensional potential well and in a two-dimensional harmonic oscillator. What we'll see today is angular momentum. Angular momentum, by definition, is talking about something that has more than one dimension. Therefore, again, we expect to have degeneracy. We expect to have more than one state for at least some of the energies. So we will start with Cartesian coordinates very fast. We'll move to spherical coordinates. And then we'll leave both of them to move to the operators. Instead of A and A Degel, it's going to be L and L Degel, and a few other ones. It's going to be fun. Almost everything that I'm teaching today is in this document that you can see behind you. The same thing from the last time. Come on, I headed downstairs, I just assumed it's going to be here. Now I need to actually look at it every few minutes. So, you know that in general.
Whoa.
You know that in general, L is R cross P, right? Now, what it means is X, Y, Z, X, Y, Z, Px, Py, Pz, hat, 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 this, which is, in X hat, I have Y, Pz minus Z, Y, plus Y hat, where I have,
XPZ minus ZPX.
I'm gonna trust this guy.
No, it's the opposite before.
What?
You forgot the minus.
Ah.
I should never trust you. Plus Z hat, don't answer, okay?
It's supposed to be the
know
minus
what?
before the Y
You
hat.
know what?
Before
I'm
the Y
gonna
hat.
let you an opportunity to fix it. Can you please? Oh, help me here. Help me here. Help me here.
Yes. XPY minus PXY. YPX. It's multiplication.
No, but
No, but that's the whole
you.
point. Because
They
they're gonna
don't
move
use-
stuff to quantum mechanics, and then it does matter. Aye. I'm really trying. בעבר, כן?
What?
בעבר.
בעבר הבא.
יופי. Okay, so this, that means with love, that I'm not doing it against him. The against him part will be in the exam. So this was what we spoke about. Regular mechanics. Now that we move to quantum mechanics, we're just going to have operator signs on all of them. So it can be with hats or something. Or you can write op on all of them if it makes you feel any better. So I'm gonna call this thing I'm gonna call Lx, and this thing I'm gonna call Ly, and this thing I'm gonna call Ben.
LZ.
Good, now we're good. Okay. What? Okay. So now what is let's say Ly. Ly is ZPX minus XPZ. I want to show now that Ly is minus IH bar. Sorry, just a second. I was really counting on here. Minus IH bar times Z ddx minus x ddz. This is very easy to see. If you take the IH bar out of each of them, remember that pz is minus IH bar ddz, right? So it's very easy to see this thing. I want to show that it is also minus IH bar cosine phi times d theta plus cosine theta sine phi divided by sine theta d phi. It's trivial to see, right? What? Were you being sarcastic now, nodding?
No, of course not.
Do you see it? It's trivial?
No.
Okay, it's not trivial. It's disgusting. How do you do this? So, I am debating how much to spend time doing it. I will definitely do the beginning, and you're going to tell me if you're interested in actually seeing all the steps, or just seeing it in the document later by yourselves, or never seeing it. I'll tell you what's the point. Of course, I'm going to want to move from Cartesian coordinates to something else. Of course, it makes a lot of sense that it would be way more convenient to talk about spherical coordinates, which is what we're going to do later. We're going to talk about Harmonious spheroid. Spherical harmonics or harmonical spheres? Spherical harmonics, okay. And I got confused about those. Spherical harmonics. Spherical harmonics, of course, are written in the language of spherical coordinates, of theta and phi. So we're not going to want to work with this. We're going to want to work with this, right? Now, as a matter of fact, we're also not going to work with this at all. We're just going to write with certain abstract LMs. We're not going to deal with this. But it is important for you to understand that the YLMs are coming from a simple translation from Cartesian to spherical coordinates. I'm going to start developing this, and at some point I'll give it. So, how do you even start this? I want to know what is dou f, dou x, where f is a certain function of theta and phi. Do you see the green? In general, you don't see the green as well in the recording, in the whiteboard, whatever. So, it is dou f to dou r times dou r dou x plus dou f dou theta times dou theta dou x plus dou f dou phi dou x. That makes sense. I need to define exactly what are my spherical coordinates. So as you know, r goes from 0 to infinity. This is not going to be relevant at all today. Meaning at the beginning maybe, when I'm going to do the derivatives. But in general, when I actually solve problems, it will not be relevant. I'm not talking about the limits, I'm talking about r in general. How so? For the simple reason that the semester is short. It's supposed to be a longer semester where you have also the hydrogen atom, where the radius of the electron around the origin, of course, changes. But you don't need to know that. No hydrogen atom anymore. We don't exist. We're before the Big Bang. We're before the Big Bang. Now theta, this is supposed to be a joke, whatever. Now theta is going to be the angle going from 0 to pi. And phi is going to be the angle going from 0 to 2 pi. What? This is the usual convention. Last year you decided, of course, that you did the opposite, which was just meant to confuse you. You know that z is going to be r cosine theta. X will be r
Sin phi cosine sin theta cosine phi. Sin.
Okay, so I have these, and I can also do the opposite. What is r theta and phi as a function of x, y, and z? So dou f dou r, I don't know what it is, right? Because I don't know what f is. It's going to be part of this derivative, right? What I do want to know at the end is, you know what, I'll do it this way. Dou x is going to be dou r dou x times dou r, etc. Meaning I don't want to. So what I'm curious in right now is understanding what this is, what this is, and what this is.
You want the operator. You don't want
Exactly. I don't want the derivative of the specific function f. So let's move to the other translation, where r is the square root of x squared plus y squared plus z squared. Theta is z over x squared plus y squared, right?
Z squared.
No, z over this. Right? What?
Remember.
No, you're not supposed to remember. You're supposed to understand.
No, I understand why. I don't remember
You have
theta
this.
is true. No, it seems right.
This angle theta,
Yes, this
sorry,
is just
this angle theta,
just Pythagoras.
it's going to be,
Should-
so I did the opposite. It's supposed to be this divided by that, so I did the opposite. Theta, it's really annoying. I'm used to having it on this screen. I'm going to use this notation. Theta is going to be cos minus 1 of z over r. You can also write it this way. Z over square root of x squared plus y squared plus z squared, which is cos minus 1 of this divided by r. It's simply, well, I got back to theta. Is that what I meant to do?
cosine,
Yeah.
cosine of theta.
No, I'm just gonna stay with this for a second. Now I want to do the derivative of this with respect to x. I want to find this. Okay? What is dot theta to dot x? It is d dx of this thing. Z over, not this, is d dx of cos minus 1 of this thing. This is not nice. What is the derivative of arc cos? It is something not nice. 1 over the square root of this minus this square. It is! I should have really, I'm debating if I should go downstairs 3 floors to get my document. It is 1 over square root of 1 minus this thing squared, z squared over x squared plus y squared plus z squared, times the inner derivative of this thing, which is zx divided by this thing to the 3/2. I have here x squared.
This is also a very derivative. X square plus y square.
But you're not supposed to do it. You're supposed to do just the inner derivative of this. And the z here is a number. Only I derive with respect to x. And the x is in the denominator of this. You have times 2x here and times 2 here. We good now?
Yes, yes.
Good. Now I want to change all this to be in the language of r, theta, and phi. Go first.
אתה רוצה לקחת אחד מהטאבלטים שלך?
ללכת ככה?
לא יודע.
זה מפריע מדי?
שיקל עליך.
This is that it's cosine theta cosine phi divided by r. It's easy to see, right? What?
The x squared plus y squared plus
What?
z squared is r.
Yes. Let's look at the, okay. Well, about the numerator, I have here r cos theta. Let's actually do it. In the numerator, I have r cos theta, which is z, times r sine theta sine phi. Okay? Here, I wish to multiply this. I want to write this as x squared plus y squared plus z squared over x squared plus y squared plus z squared. Okay? So what I have here is square root of
X square plus y square.
x squared plus y squared
Divided by x square plus y
divided by
square.
r times
R square.
r squared, of course. Okay? And here what I have is r
2r to third.
r to the third.
Yes.
Okay?
2r to the third.
No, the 2 and 2
Ah,
are added
two.
because of you.
Yes, yes, yes.
R to the third. Okay, now I take another color, and I have a red with me that I haven't used yet today. So this and this kills that. Right? I have here a square root of r inside here. So it's an r. It kills one of them, and this kills another one of them.
X squared plus y squared gives you r.
This
sine
is-
theta. R sine-
And here I have, you know what? Instead of x squared plus y squared,
R sine theta.
I can write here r squared
Sine theta
sine theta squared. So now, the way I did it now, is that this we cancel with that. This, one of them, sorry, not both of them. The two here will be cancelled with that. And I'm left with cosine theta sine phi divided by r, and I have here also a sine theta.
No.
No, I don't, because it was in the square root. I got what I needed. Good. So I did this. In the same manner, I can do this and that. It could be again doing the derivative and all those things. Is there anyone here who's actually interested in that? Okay, Ben wants, so we'll do it. You can all blame Ben. You can all see it here in the document. It's really not interesting. It's very technical. You're just doing derivative and not missing any minus and any inner derivative. You know what? Look here. Oh no, wait a second, too much. Here, this is a good size. You can look to the back. I have theta, which is r cosine of this, and I do the derivative, d theta dx gives me this. Then phi is arctangens of y over x. I do the inner derivative with respect to x. I translate that to spherical coordinates, and I get another term, which is this disgusting thing. Finally, I do the derivative. Oh, and there's also the x. Then I put all them together. d dx of f is something times df dr, something times df d theta, and something times df d phi. I'm going to write it where all this goes outside. The f goes outside, and I write it as a general derivative. And from here I can conclude that d dx is this thing. Okay? What happens now? What I'm interested at the end now is Ly. Ly consists of px and pz. Px and pz are built with ddx and ddz, right? I can here also get, in the same manner, the ddy is this, and ddz is this. And now when I wish to do Ly, it's this times z, and this times x, and do the subtraction between them. Z ddx minus x ddy gives me, I plug in whatever needs to be plugged in, and then I finally get this. Okay, so it is very, very technical, but at the end I get derivatives. All good. Now we're happy. Thank you for bearing with me. Now, let's forget all this. Who cares about actual derivatives of theta and phi? We don't like them. They're disgusting, as you can see. They are confusing, as you can see. Instead, we're going to work with operators L, Lx, Ly, and Z, etc. So, you already know that every potential and every Hamiltonian has its eigenstates and eigenvalues. We spoke about harmonic oscillator where you had the Hermite polynomials times a certain exponent. Did Richard show you how we get to these Hermite polynomials? Did you do all the... There's a few ways to get there.
We didn't solve the differential equation.
You did not solve the differential equation?
With the Frobenius method.
You did or you did not?
No.
Oh, come on, that's so beautiful. Who remembers Frobenius method? From Israelis, you learned it in the course ODE, ordinary differential equation, where you plug in the general polynomial, etc., right?
Yes.
Then you see the recursion and all those things. So this is one of the ways to get to the Hermite polynomials in the problem of harmonic oscillator, and it's beautiful.
Yes.
Yes, and then you can see where the quantization comes from also.
Because the Frobenius.
Because you want it to not diverge. Because you want the polynomial to not diverge, you must cut it somehow. When you cut it, it gives you like you want a certain n on the polynomial to be 0. One of the a-n's to be 0.
You can also write it as another power of the variable to generalize the method, and you don't have to put the polynomial.
It's fun. If you want, I can give you a link to a lecture of Eddie Bolkei doing it. I find it beautiful. Okay, now let's talk about the general operators that we're going to talk about it. We're going to talk about the states Lm. What operators do we have? We have L squared, which is Lx squared plus Ly squared plus Lz squared. I'm going to have Lx, Ly, Lz, and L plus, L minus. These are all the operators I'm going to talk about. I want to see what each of them does to the wave function. Okay? When L squared acts on Lm, what units does L squared have?
H bar squared.
Oh, good. So it's going to give me H bar squared times L plus 1 times Lm. Meaning it does not change the value, it does not change the wave function. It is an this is an eigenstate on L squared. Where L
How do you assume it get out L plus 1?
what?
How do you assume it get out?
I just tell you.
Alright.
It is known.
It's from the differential equation.
When Lz acts on Lm, what units do I expect? Very good, H bar. So I get H bar m times Lm. The next thing is going to be L plus and L minus. Where L plus, well, L plus is Lx plus I Ly. L minus is Lx minus I Ly. These are their definitions. Okay. I should give you, wait a second, where is the thing? Here. When L plus acts on a certain state Lm, it will rise up the m level. What will it do? H bar times square root of something disgusting, L plus 1 minus m plus 1. How do you remember that? Times L m plus 1. When L minus acts on Lm, it gives me H bar, square root of the same thing, L plus 1 minus m minus 1 on L, m minus 1. There's a lot more to write. Where L plus acts, in general, I did not say it yet today, but I'm sure you all know it, that in general, the m go from minus L to minus 1L. Therefore, the degeneracy is 2L plus 1. Degeneracy is usually written with the letter G for some reason. Meaning if L is equal, let's do a small chart here just to understand that. L, M, G. If L is 0, and it can be 0, how many options do I have for M?
1.
I have one option. If L is 1, so M can be minus 1 or 0 or 1, I have 3 options. If L is 2, so I have here minus 2, minus 1, 0, 1, 2, that's 5. The number here is twice the number here, plus 1.
You can also have half integers, right?
Not in this course. You can, definitely. This is where the spin comes in, but it won't be in this course, unfortunately. When L plus acts on a certain wave function, it rises up the m. What do you mean act? It's not something physical. L plus is not something that I know what it is. It's a certain combination of two real operators One of them you multiply with the number I that doesn't really exist. So what does acting L plus mean? I don't know what it means, but I do know how to work with it. So L plus brings it up a level, L minus brings it down a level, and I have, of course, a certain number coming as a constant. The units that I have are h bar, as I expect. When L plus acts on L, meaning I'm already at the top level, I can't go up. I can't have here, when M is 1, I cannot have M equals 2. How do I see it here? It is supposed to be h bar times square root of, I plug in this. L plus 1 minus L plus 1 on L plus 1. But this here is 0. Same thing if I try to bring something down a level when it's already at the lowest of it. L minus and L minus L, I expect the constant here to be 0. I have h bar square root of L plus 1. I'm supposed to write now minus M. But M is minus L, so I have here plus L, and here I'm supposed to write minus L minus 1, right? Hey, it's 0 again. Times L minus L minus 1, which is 0. So I can't go down, I can't lower than M cannot be lower than minus L, and it cannot be higher than plus L. What else do I have here? Of course I can say, if you ask what is Lx, you have here a certain wave function. And I want to know what is Lx. What is the mean of Lx? How do I do this?
You use it as a linear combination of the.
Exactly, I'm going to say Lx is going to be L plus
Plus L minus divided by 2.
plus Ly divided by 2, and Ly is going to be Ly minus, sorry, not Ly, Lx.
L plus minus y.
Minus Ly divided by 2i.
Yes.
Okay, so I almost finished. What I'm left with is to tell you what is the commutation relation. Commutation, of course, you ready?
Ly.
It's L minus.
Thank you. So, as I expect, L squared with Lx squared is going to be 0. What I just erased now, and I should have mentioned before, is that L squared is Lx squared plus Ly squared plus Lz squared. Therefore, the commutator of L squared with Lx squared is going to be 0. It's going to be like the commutator of Lx Ly squared. It's going to be the commutator of L squared and Lz squared, which are going to be 0. Okay. Can you know the total angular momentum and the angular momentum of z with respect to z?
Yes.
Yes. Rotation.
L squared and Lz are also going to be 0. How do I know that? Because they share the same eigenstates. Meaning, when I solve these problems, I want to choose one axis as the special one, and the one I choose is z. Where z? Wherever I want. So, free of choice. But I choose one axis as the special one that share the same eigenstates as L squared. What is Lx and y, or in general, this I showed last week, it is
H bar.
IH bar, no? I don't remember.
IH bar.
I think it's IH bar and Z,
The Levi-Civita symbol.
Levi-Civita symbol, etc. Am I missing something that I wanted to say? I think not. X and Y, okay. That's basically it. Okay. Okay. So all this I will erase soon. Before I erase that, I want to ask you a question that will show me if you understood what I said or not. I want to know if is it possible that my entire angular momentum will be towards the z-axis? The answer is no. Uncertainty and stuff like that. But how do I show it using what's now on the whiteboard? In the past 10 minutes.
You take the eigenvalue of L square, and you see that LZ never can get up to that.
Exactly. I want to show this. Did you fully understand that, or should I show it? I think I should show it. I have now a certain state, L, Lm. M can be anything, it can be minus L, plus L, whatever. I want to see what is Lz squared on Lm. And I want to know, can it be equal to L squared on Lm? Is it possible? In words I understand what it means. You understand that this, if the answer is yes, it means that it's possible that all your angular momentum is going to be towards z. You understand? Okay, translate to the same thing. Let's show. What is L squared? Do you see down here or not anymore?
No.
Not anymore. L squared on Lm, I already know what it is. It is h bar squared times
L plus 1.
L plus 1 on the same Ln. Of course, it does not depend on the value of m. Lz on Lm, this is Lz squared, right? Is Lz on this acts on this, it gives me h bar m.
H bar m.
H bar m on Lm. Which is, now I can change the order, of course, h bar m Lz on Lm. This gives me another h bar squared m squared on Lm.
Which is always
Now, even if this can be closest to this, if,
M
equals
to L.
right, if m equals L, it is h bar squared L squared times whatever, and it is smaller than h bar squared L squared plus h bar squared L. Therefore, L is positive always, right? L is positive. It's an integer bigger than 1. Bigger, 0, 1, 2, etc. It's non-negative. Okay, so it is not possible. However, when L is very big, it can be already all the same, right? L big, high energies, classical mechanics. Can you have something spinning at one very specific direction with only one dimension, where the entire angular momentum is towards the ceiling? Yes, I can see it here with high energies, with high L's.
L squared is way bigger than L.
Yeah, L squared is bigger than L, or equal if it's 0. But if L is bigger than 1, so it's almost the same. So, and this for me is a fun, basic example to show that you understood both how to work with the operators and what they mean. In general, if my angular momentum, meaning if m is equal to L, so almost all of my angular momentum is towards up. If m is equal to minus L, so almost all of it is down. If m is 0 and L is 2, so almost all of my angular momentum is to x and y. Actually, all of it this time. Okay, now that we hopefully start understanding both the math and the meaning of these operators, we can go and solve other problems. And the next problem we're going to solve is a rigid rotor. What does it mean? Imagine a ball, and you have an electron or a thing rotating around it. Why do I call it rigid? Because the R is constant. Why is the R constant? Because it's a short semester.
You can use the Runge lens vector, right?
The what?
Runge lens vector.
What's that one? Normal?
Runge lens.
Do you know what this is? Is it something Richard spoke about?
No.
Okay, you scare me.
Richard talk about quantum computer and quantum security last lecture. So we are way behind.
You did not talk about the angular momentum?
No,
Oh,
he
you
talked, but yesterday he talked
2
about
weeks
quantum
The
computer
Bell
and
inequalities
quantum security.
I don't understand. Like, am I teaching slow? Is he teaching fast? Both?
I don't know. It's a good squish.
Well, if he didn't show you Provinius, I can blame him for not thinking you Provinius.
But I think we did it in the homework, don't we?
The Provinius?
No.
I gave it to you?
Yeah, but it was on the homework.
But for spherical harmonics, not for angular momentum. Not for...
Yeah, not for the harmonic oscillator.
oscillator.
Okay. Okay. I have a rigid auto, and therefore I have a certain constant distance from the origin. I don't know how to draw it. I'm gonna try drawing it this way. Okay. This is a ball. We have a particle that's free to go on the ball wherever it wants. Okay. I think that's an okay drawing. The radius of the ball is R naught. My energy is only kinetic energy, which is p squared over 2m. Now you've seen already in the class of mechanics where you can split the energy into the... Well, let's go back to mechanics. Right? This is the velocity. When I try taking it square, so it is the multiplication of them is 0, so I have r dot squared
plus r squared
plus r squared theta dot squared, right? Here, r dot is 0 because I'm at a constant. Because semester is short, yes. Therefore, what I'm left with is the kinetic energy, which is half m v squared, is half m r squared theta dot squared,
that p squared,
which is also l squared over 2i. Then I can show you what L and what I are back in mechanics. You want it? No. No, someone wants to? L is mr cos v, and now since v dot is 0, which is m r cos r dot. And this time this is 0 because the angle is 0, so I have here mr squared theta dot. And I is
sum of r square m square. No, sum of r square m.
and here I have just mr squared because I have one particle, a small particle. So L squared over 2i is m squared r to the 4th theta dot squared over 2 what?
2m r squared.
This is L squared.
No, no. In the, no.
Divided by...
Divided by 2m.
By 2i, yes, here I want to put m squared r to the 4th. Right?
No, it's
Wow.
in
Back to the second.
m
No,
r
there you
to the second.
Yeah, sorry.
And
Good?
Yes. And
Am I wrong here? Wait a second.
it's half m
L
r
squared divided by
theta
2i.
dot squared. It's not
Which is m
half
Yeah,
m r squared.
r squared theta dot squared divided by 2, so I'm all happy. Divided by 2?
Yes, yes.
Am I-
It's okay. Yeah, yeah.
do I need to divide by 2?
Yes, yes.
Good. So we happy now?
Go.
Was this necessary? Was this a waste of time?
A little bit.
I think I like it. Okay, whatever. They're polite. You see, that's a polite guy, even though he's Israeli. He's Israeli, right? So,
Lord, you know, the best city.
what?
Very polite guy.
So therefore, I can write my energy as L squared over 2I. And now I want to know what I want to know. Well, the eigensets are going to be again now just Lm because my energies are just coming just from angular momentum. Therefore, I can ask you about a specific problem. And my specific problem is going to be now just a way for us to play with harmonical spheres. Spherical harmonics.
Spherical harmonics.
Why they
Because you
erase it.
erased it.
Spherical harmonics. So you have now a rigid auto starting at the initial state is going to be psi is a, or a is a real number, cosine of 3 theta. What are the energies?
N equal.
Let's split it to how we would actually solve it. A, we find A. B would be what
Then
are the eigen states, and C would be what is, I don't know, the mean of the energy.
A find from the normalization.
Let's find from the normalization. I want psi to be 1. But what is type psi? It is the integral
Over the rigid angle.
a squared cosine squared of 3 theta. But what is my integral now?
The solid angle.
I'm going to do it d omega, where d omega is d theta d phi.
Yes.
D theta d phi like that? That's
No, sine of theta.
it? Because of?
The Jacobi.
Jacobian.
Yeah. What was his name? Carl Gustav Jakob Jacobi.
This is also the one from the Hamilton-Jacobi equations?
Yes.
The same Jacobi?
Yes.
And his parents were Rachel and Shimon. That I find it funny. It's like very classical Jewish names of today. Or biblical.
This is the reason they were smart, because they were Jewish.
I'm not supposed to answer that. And of course, I'm gonna have the two integrals. The theta goes from 0 to pi. The phi goes from 0 to 2 pi. And this is a fun thing, right? Hint, we're told that cosine of 3 theta is 4 times cosine cubed of theta cubed בשלישית. Minus 3 cosine theta.
That's only
Trigonometrical identity?
Trigonometrical identity.
Yes, of course. It's not the regular equation sheet, so that's why it's part of the question. Now I need to solve it. It's not too hard actually. It's going to a squared. The integral of the phi just gives me 2 pi, right? Times the integral from 0 to pi. Now I'm going to do this squared. So I'm going to have here 16 cosine to the 6 of theta minus, how much is 4 times 6?
24.
Good. 24 cosine to the 4th of theta plus 9 cosine square of theta. All this times sine theta d theta. Sine theta turned out to be quite useful here, right? Let's do cos theta as u. So sine theta minus sine theta d theta is du, etc. Can I just jump ahead?
Yes.
Because doing those numbers, 16 divided by 7 is not a fun thing to do. Altogether, you get that this integral is equal to a squared times 2 pi times 34 divided by
7.
35.
Aye. Good.
Let me just tell you that. I expect the denominator to be something that has a 7 in it, something that has a 5,
and 3.
and 3. Do you know a number like that? It's amazing.
Oh.
Okay. Not really a 3 because I have the 9 canceling it out. So that's not good. Therefore, if this is 1, so I can tell you that a is going to be the square root of something disgusting. A is going to be 1/2 the square root of 35 divided by 17 pi. What? Good. So we found A. Now I need to find the eigenstates. What is the way to do that?
To go as the spherical harmonic.
Yes, I need to go back to the chart of spherical harmonics. If no one remembers, they should be part of your equation sheet. Do you have equation sheets in the middle?
Yes.
We have an open
Open
material.
Good. So this is supposed to be part of your open material because
Wow.
on the one hand, you're not supposed to remember it. I'll make it a little bigger. You're not supposed to remember. Oh, come on. It's going to give you a headache. Close your eyes. Here. Okay. So, you're not supposed to remember what are y0, 0, y1 minus 1, y1, 0, etc., etc. But you do need to use them in such questions. Because I do use, at the end of the day, I do use the fact that it's spherical harmonics. I need to remember those spherical coordinates, where the spherical harmonic come from. Here, what I have is a certain function of theta.
I use the decomposition you did of the, right?
Oh, wait a second. Let's just hunt for cosine cubed and cosine. There's no function of phi, so it gives me a hint that my phi are 0. If I would have a constant number, if I would have here a 3, then I would use y0, 0. I really want to make sure that what happens if I... Here. No, very good. We'll find it soon. This is giving me a headache as well. Come on! That's settled it. List. I should just search the word list. So, the first one is just a constant. Do I have a constant here? No. The second one has a function of phi. Specifically, it is a function of minus phi because it has a minus here. Therefore, I go hunting for the next one. Ooh, this one seems relevant. There's a cosine theta here. Let's remember this one. We'll write it down. Cosine the y1, 0, which is y L equals 1, M equals 0, is, oh, it's here, half sort of 3 over pi cosine theta. Let's hunt for the next one. Ooh, you get your sine squared. Will I have a cosine cube? Come on, higher dimensions. Doesn't have it.
M is 0 because we don't have it's
What? So, I have here, no, it is here. I have here this thing, okay? If you would have one more on the list, in the Israeli Wikipedia, they have more.
כן,
The Hebrew one.
The English one too, they have another article dedicated to the table.
Okay, so you should have it because I could ask it on the exam. I do not see the exam yet. I could, as if I'm writing the exam. What I have here is a cosine cube, but it's not by itself. And you have here that y y30 is equal to square root of 7 over 16 pi times 5 cosine cubed of theta minus 3 cosine theta. I just erased A, which was a mistake. Okay, so now cosine of 3 theta is something cosine cube and something cosine theta. I know that cosine theta is simply y10 times something.
2 square root of pi to.
Let's just write square root of pi divided by
3 multiplied.
12. No?
Ah, we get it to
Oh.
delve into. Yes.
4 pi over 3.
Yes.
Like this, okay? What? Okay. Y 5 cosine cubed of theta is equal to square root of 16 pi divided by 7 y30 plus 3 times cosine theta, right? But what is cosine theta? Instead of cosine theta, I can write here
y10.
y10 times square root of 4 pi over 3. Wait a second. Now I can write that
4 cos.
4 cosine cubed of theta is going to be this thing. You multiply by 4 and divide by 5. 4 over 5. Square root of 16 pi over 7. y30 plus 3 y10 divided by 4 pi over 3. But this is the 4 times cosine cubed. I want to take off from it.
3 cosine theta.
So minus 3 cosine theta plus this is like this, minus
3y10.
3 y10 square root of 4 pi over 3. At the end of the day, well, wait a second, but all this was multiplied by a, right? As I found before. I can multiply all this by a.
The L equal 1 harmonic oscillator.
What?
I forgot to multiply the plus 1 in 4 divided by 5 because they multiply both
Yes.
sides.
What?
It can cancel it.
The 4 divided by 5 stops here, right?
Yes, we need a bracket.
Okay. So from here, I can now try to find, this is my initial wave function. I can end up by writing this psi is equal a certain constant times y30, that's called C3, plus another one of y10, right? So now I can ask, what is the chance of finding the particle with L equals 2?
0.
What is the chance of finding a particle with L equals 3?
C squared.
C3 squared. Well, scared that you won't say the square. And what is the mean energy? Can be C. The mean energy is going to be, in general, it is a summation of Ci squared EI the chance, this is just the definition of a mean, right? The chance to be in a place times the height. The chance of me finding someone with specific height, the mean height is the chance of me finding someone tall times its height, plus the chance of me finding someone short times its height, etc. Right? Good. So the mean thing is going to be C3 squared. So should I tell you what C3 is? It's not a nice number. Let's just go down here. We're still to you since you're already using this class as an exercise for your neck. This is the number at the end. Beautiful, isn't it? This is C3, and this is C1. Okay? Not so bad. So there's whatever. The chance of 24.71% of finding it is with L equals 1, and all the rest with L equals 3. And of course, a good way to make sure that I did not make a mistake is
לבדוק שהם אחד.
C1 squared plus C3 squared must be 1. Okay. Now what is the energy of each one of them? I know what the energy is, right? L squared over 2I Lm Lm. If I have here 3, so it's 3, 0. L squared 3, 0 divided by 2I.
1.
I'm going to finish this exercise properly. So, my mean energy is going to be C1 squared over 2I times 1, 0, L squared 1, 0 plus
C3.
C3 squared like this.
Why do you say
What?
why not like C1?
Oh, yeah, because of 2I. I wanted the 2I to be once. No brackets. Lose the brackets. There's the same I. But okay. This will be at the end my mean energy. The I's I know what they are. C1 and C3 I found. They're written behind you, or before they were written behind you. They're over here. And what is my L squared acting on this?
Is 1. It's check. 2. H bar square. 1.
It is times 1 times 2.
1.
So I have h bar squared over 2I times C1 squared multiplied by something, and C3 squared multiplied by something. Here it multiplies 2, and here it multiplies times
12.
Very good, 12. This is my mean energy. Good. Short break. What's your name?
Leo.
Leo. Tell us about yourself and why you didn't come throughout the semester to my classes.
I was at home. I was seeing you on 2-speed.
Oh, I was in
2-speed. And
It's possible?
now you're talking slow to me. It's possible.
Usually I'm told that.
Yeah.
I put you in 0.8.
Yeah, I feel like this is a big compliment. This isn't
I
something.
don't know. I putting you on 2 and putting the Tagul is in one window.
Exercise.
Tagul.
I have a friend.
Exercise. TH
Tutorial. So I have a friend who met his professor. Met a professor after a while. And he hasn't seen him. And then he speaks to him and he thinks that he's like in shock to see how not well he's doing. He's sure that maybe it was a brain problem, maybe he's very sick, that he's speaking so slow. And then he realizes that he's just used to hearing this professor speaking at times 2.
Yeah.
Okay. You felt bad. I'm so sorry. I didn't know what happened. And then later on, you realize nothing happened. Okay, next thing while I was whiteboard, Joseph is going to tell us about Bar Ilan as opposed to his previous university.
What do you want me to tell you?
I don't know, whatever you want. You have like 40 seconds until I finish.
In my last university, everything was in Spanish. It's different from Bar Ilan.
Where everything is in Hebrew.
Right. Some things are here in English, and they share that some courses there also were in English, so that they can come.
Okay. We're going to have you now another exercise where we play around with L plus and L minus.
I have a fun fact actually. The food in my past university costed like 50 magburot.
And then it's like,
Because it's
how many times this per meal?
right.
Is everything in Mexico way cheaper?
No, it's because the government pays for the food in my university.
Oh. Are they looking for students or something?
Can we go to Mexico? There is a student
Exchange.
Yeah?
Yeah, sure.
Let's do it. Let's go to Mexico.
Okay, Mexico, right?
Mexico, yes.
So now I have a weird Hamiltonian, okay? And I don't understand what made it and how it came to the world, but we have a Hamiltonian and it's described by, oh, you can't see it. You have here H operator, which is a certain A over H bar. L plus L minus. I do not need the brackets. Minus B over H bar. Lx squared plus Ly squared. Okay? Now, what are we
What the unit of A and B?
no, A and B. No. We were told that A and B are real.
Why?
They're not necessarily the same. They're definitely not the same units. But A and B are. Oh, sorry, they are the same units. So this is like L squared.
times L.
They're the same units. You are A and B are real. You're asked show that this operator is Hermitian. This Hamiltonian is Hermitian, and find its eigenenergies and eigenstates. Okay. The eigenstates are probably going to be harmonic spheres. Circular harmonics. I said it. The eigenstates are going to be circular harmonics, but the eigenenergies are not going to be h bar squared L plus 1. So it will be something weird because it is a weird Hamiltonian. Now the test for any question about angular momentum is that if you have Lx and Ly, the first thing you want to do is get rid of them.
And right, LZ.
You can write L squared, Lz, L plus, and L minus. We don't like Lx and Ly. Okay, therefore I'm going to write H as A over H bar.
L plus and minus.
L plus L minus. What is L plus L
Multiply.
minus?
It's Lx plus Ly.
Let's do it inside for a second. L plus is Lx plus I Ly. L minus is Lx minus I Ly.
Is Lx
L plus L
squared.
minus
Lx
is
squared
equally
plus
Lx
Ly
squared
squared.
plus Ly squared, right? Minus I squared Ly squared. Okay, which is L squared minus Lz squared. I don't like Lx and Ly.
And then
Therefore,
A plus B H bar.
I'm gonna write here
Two.
A. Wait. A.
B?
Huh? I have L squared minus Lz squared minus B over H bar. Here I have again
Square.
L squared minus Lz squared. I think I made a mistake here.
No. Seems very good.
No, because they don't commute, right? In that part is are a little bit different.
Yeah. You're right, wait a second. You're right, yeah. This was easy for I did here.
Why is it like?
In general, you should always try going away from Lx and Ly, and you should never ever believe them. Lx plus I Ly times Lx minus I Ly is Lx squared. Lx minus I Ly, so minus I Lx Ly plus I Ly Lx plus Ly squared. So Lx squared plus Ly squared, but this thing here is
It's not 0.
like Lx squared plus Ly squared
It's a commutate.
minus I Lx Ly. But what is this thing?
IH bar.
H bar Z.
Something like
Together
this.
with the minus I.
Yes.
I H bar and Z. How did I know that there's an H bar here?
Because the M
Because Lx times Ly
it has
must
to be H bar squared the unit.
Yes. So, altogether I have here Lx squared plus Ly squared plus H bar
LZ.
LZ. Yay. Good. So, I have here L squared minus LZ squared plus H bar LZ.
You have the same, but you have to add
L squared minus LZ squared
plus.
plus H bar LZ. Altogether, I have here H is equal to A minus B over H bar, and here I have L squared minus LZ squared, right?
You have to add the.
Plus
A divided by H bar.
A divide, no,
Without just A. LZ.
Good. Now, let's show that this is Hermitian. Is this Hermitian?
Yes.
Is this Hermitian?
Yes.
Is this Hermitian?
Yes.
That's it. I could also show already here that it's Hermitian. Because this is Hermitian, this is Hermitian, and L plus, L minus is also Hermitian. Because if you take the dagger of it, it is like L minus dagger, L plus dagger. When you do the dagger on something in brackets, you also change the order. L minus dagger is L plus, L minus, which is what I started with. So an operator that if you do dagger and you get the same thing again, so it is Hermitian. Yes. So we found that it's Hermitian and we made them implement to be way nicer. What are the eigenenergies? Very easy. We just do a sandwich with a LM. I see that the eigenstates are the if I already know that the eigenstates of LZ and L squared are shared with each other and shared with, and they're just a superposition of them, so all I get now is the eigenstates of YLMs. What happens if H acts on LM? So I would get A minus B over H bar L squared on LM minus, we'll do the slowest I can, minus LZ square over LM plus LZ over LM. what I get here is something times del m a minus b over h bar. Here I get L plus 1, but times h bar squared. In general, I'm going to have times h bar squared, so it's all going to be with h bar. I can add here an h bar. I'm going to have a minus b times L plus 1, and here I have minus m squared, right?
Right.
Plus
You have to close the brackets first.
a m.
There's not supposed to be a H bar because
No, it's
yeah,
not.
H bar. Ah,
I put the h bar also for units and etc. etc. Of course, the numbers N and M are just numbers; they're dimensionless. And I get here, the same thing that's written here. Of course, I got something different than a regular, than the original. Although I got here very weird energy levels, but that's what I have for this weird Hamiltonian. Okay, I want to conclude what we saw today about spherical harmonics. What we saw was that we have something that has more than one dimension, and for sure we're going to have degeneracy. We're going to have a few states for the same energy. We started with Cartesian stuff, showing you that everything goes back to all mechanics, the way that we started. Only that this time we have commute. Some they don't commute. We just move to spherical harmonics, and we get a certain function. And I just told you, I did not figure anything. The spherical harmonic are a solution. From here, we tried as much as we can to forget it and just work with clean operators. The ones we like most are L squared and LZ. The next one we like is L plus and L minus. We don't like them as much because they're messy. And we definitely do not like Lx and Ly. When we are asked about Lx and Ly, we can translate it back to L plus and L minus. We do need to understand at the end what those spherical harmonics are, because sometimes we can ask you about a certain weird initial state, etc. Besides that, everything works like usual stuff in quantum mechanics, where the mean energy is the chance squared times the summation of Cn squared Em, and we can make up weird Hamiltonians. I think that's what I wanted to say.
this is the end of the semester, and you love
Yes.
us all, and you will miss us.
No. Not that. The kind of questions that I did not look at the homework that I want to give you today yet, but the kind of questions that we sometimes had in harmonic oscillator, where I am at state psi is equal to I don't know 1 plus 2 times 3 plus 71 times 4 times a certain normalization constant, right? And then I asked you, what is the mean of x, right? And what you did here is that we translated it to a and a again, and then we saw that the 1 and the 3 are never going to talk to each other unless you have x squared, and the 3 and the 4 are going to talk to each other, etc., right?
Not this one, actually. The one.
The 3 and 4.
This with the psi consequence.
Yes, psi equals psi.
Yes, but not.
Yeah, you're right. When I do a on the
Yes,
4, it will
yes.
talk to the 3 here. When I do
Yes.
a dagger to the 3, it will talk
Yeah.
to the 4. Okay. And the 1 is not going to do anything. I can do the exact same thing here in the case of angular momentum. What will be the parallel of this? I'm going to have here a
Plus.
few LMs. I'm going to have L plus and L minus. It'll be the exact same thing. But let's say I have here, I don't know, 2, 1 plus 2, 0 plus 1, 1 times Lx. Okay, so I'm going to do here L plus
L plus plus and minus.
plus L
Plus and
minus.
minus divided, multiplied by L.
Oh,
Okay.
No, without that.
Whatever, something. Okay? Divided by 2i, no?
No.
no, without the I.
The I is when you want Ly.
Okay, this thing is Lx, okay? And then I'm gonna have here 2, 1 plus
2, 0,
2, 0 plus 1, 1. Do you see that it's parallel to that? Okay, now let's see just which terms are going to be relevant. Now, all the LMs are orthogonal to each other. If the L or M are different, there won't be any communication. This thing and this thing are never going to talk to each other because the L changes only the M value. L plus and L minus change only the M. So this and this have a different L, they're never going to talk to each other. What will I have? When L minus
2, 0,
acts on
and
this,
1.
it's going to be friendly with this guy. And when L plus meets him, it's going to be
Finally,
have a very close relationship with
first one.
this guy. Okay, so I don't need to do the whole terms. So the exact same thing I did here, I can do here, and I can be mean and ask you to do Lx squared. Not so bad. It's going to be L plus L minus squared. It's going to be L plus squared plus L minus squared. That's it, right?
No.
Oh, sorry. Plus 2L plus L minus.
No!
No!
I was afraid.
Plus L plus L minus L plus. Right? And here, each one of them is going to talk to its original guy, right? If you do L plus L minus to them,
L plus squared is like doing L plus twice.
right.
So L plus squared doesn't really help us. Sorry.
In this case,
In this case.
correct. But
So,
these two
these
will
two
definitely
actually,
contribute, right? I was Emmanuel. Thank you for listening. It's good you applaud now before I upload the homework.
חייב להעלות את
לא, אולי נבטל
הספיק האחרון וזהו. מה שהראית עכשיו.
נעשה כזה L פלוס L מיינס מתקזז.
If you want, I can get. Would you want me to upload an exercise with no submission?
Yes.
The
Because
last one.
I do need you to exercise it because it's part of the material for the exam. Right? Yes,
No,
HR.
of course.
Because in the exam he said yes. So I have no problem uploading in homework, maybe even with solutions, and for you to do it whenever you want. Should we do that?
Yes.
Yeah.
When you look at it?
Yes, yes. Really good. Before the test, really good.
Yeah.
I trust you. I want you.
You can do the submission like 2 weeks or 3 weeks. It's the same.
Should I do that? Should I give you a submission in a month?
Yeah.
Yeah.
I think.
Okay. So I will give you a submission just in a month.
Like 1 day before the exam.
When is the exam?
For
No, 1 day before the exam is bad because then you're going to be busy doing homework instead of going for the exam. I don't want that.
So
Because
just without submission, it will be.
if it's not submission, I think there's a chance that somebody won't look at it and then you won't be ready for the exam. I don't care about the grade. I have enough. I've given you enough. I have given you enough homework for the semester.
Yeah.
You know what? I'll give it to you and I'll tell you to submit only 1 question out of it. Okay?
Okay.
In a month or in a few weeks. Because I definitely want you to open it and to look at it and to.
פגש בטלפון.
בגלל מה?
בתרמודינמיקה. סמסטר הבא אתה מתרגל?
רשום אותך.
אתה לא מתרגל בתרמו שלך? סמסטר הבא?
רשום אותך, כן, אבל בסדר.
I believe you, but I don't
אנחנו
know.
נרשמנו אליך.
But I don't know.
בסדר, אבל לא יודע טוב.
מה? אתה לא יודע תרמו.
לא,
זה מצחיק, כאילו, לא זוכרים את הדברים האלה, נכון? כאילו שכאילו עוברים את הדברים,
כאילו בינה.
נגיד וואי בינה.
יותר גרוע מזה, כאילו אני אגיד לך באמת, אני לא
לא,
כל אחד והחוויה שלו. אני מרגיש שלא הבנתי אף קורס שאני מלמד.
נכון, אמרת, סיפרת לנו בממפיס.
ביקשתי ללמד.
קוונטים כי רצית לדעת קוונטים.
אני קוונטים, רציתי לדעת קוונטים, אבל כאילו, את כל מה אני חושב, אני די בטוח בוא נגיד, באחד קוונטים, באחד קיבלתי 69, כמו שזכור. לא ציון מורשים במיוחד.
אבל עשית באנגלית או בעברית?
בעברית שם. אבל אני חושב שגם מה שעשיתי, פשוט כאילו טחנתי אינטגרציות בחלקים, כי הבנתי, נתון כזה עושים אינטגרציה בחלקים. לא באמת הבנתי מה זה פרוטגרציה.
אז ריצ'רד אתמול הסביר לנו שהמבחן ממש לא יהיה טכני.
כאילו אם אתה מגיע לאינטגרציה אתה בבעיה. אם אתה כותב את פעולת האינטגרל,
הוא אמר אם אתה יודע את התיאוריה ואתה יודע את החשיבה מאחורי הדברים, אתה יכול לציין את
כאילו אני רק נוטיישן מקצר את המבחן ב-88.
יופי, אז אני, כאילו, יכול להיות שזה, קיצור, יכול להיות שאני גם, הזיכרון שלי קצת משחיר את הידע שלי מהעבר. לגמרי יכול להיות, זה קורה. אבל,
בסדר, מה יהיה טוב? אתה אוהב חשמל, לא? זה היה, כאילו, זה היה...
חשמל?
כאילו, מוליכות לא?
דינמיקה של אוכלוסיות.
מה?
הוא אוהב בכלל עברית, הוא יש לו תואר שלישי.
דינמיקת אוכלוסיות? מה זאת אומרת?
זה עם הקפריסי, נכון? זה מה שראינו אתמול.
מה הקשר?
לא יודע, ראינו אתמול איזה מבחן.
זה איך קוראים לזה? אוריאל עושה דבר.
גורדינסקי.
שתרגל
אני לא יודע להגיד את השם שלו.
מה זה אבל זה דינמיקה?
זה הוא ויעל יום.
לא,
יעל הזאתי
אני עכשיו מורה בתיכון.
באמת?
בתחילת השנה.
באיזה תיכון?
תיכון אדם.
לפיזיקה?
לא, אנגלית ומשנה.
מיקי, יש לך תואר בפיזיקה? אמרו לך לא, אל תלמד פיזיקה, אתה יכול להגליד במשנה.
כן, ואז המורה לפיזיקה גויס, אז הכיסו אותי לפיזיקה ועכשיו הוא חלום.
אני בהלם. שבאמת זה טוב.
מה אתה מדבר אותו בפיזיקה?
לא, זה לא נורמלי, זה בסדר שבן אדם ילמד בפיזיקה.
לא, משנה הוא יודע.
בטח הוא יודע.
מה זה מודל את האוכלוסיות? החזק שורד. אתה הרי טוב קצת, נכון? יופי.
הומו ספיאנס.
אז הסבא התלמוד שלך, היה לו שתי ילדים, אחד היה קוף יותר חזק, הוא זנב ארוך ושופץ על העצים, ואחד היה קצת פחות זנב
גם פילוסופים בשביל.
איך קראו להם? הומו ארקטוס ומה היה?
אחד היה עם זנב יותר קצר, אחד היה זנב יותר קצר, ראש יותר גדול,
הומו ספיאנס.
הוא היה פחות טוב בלטפץ על עצים, אבל יותר טוב בלתכנן קצת יותר טוב. נכון? היית טוב במשהו, נכון? ולאגור בנו, נכון? ואז היה הפיצול שלו עם זה. איך קרה הפיצול הזה? אחד הוא חזק יותר מהשני?
משהו אחד.
זה קטע הישרדותי אבל.
אבל זה אחד המולד את השני, לא יודע מה יותר טוב, לא יודע מה הסיבוב. איך יש יותר משני מינים? איך יש יותר מסוגים של צמחים?
אחד צחק יותר מהשני.
איך יש מלא גזעים של כלבים? מלא.
אחד, אבל יש אזורים בעולם וכל אחד מסתכל על האזור שלו.
סבבה, איך באזור של מדינת ישראל יש יותר מסוג אחד של צמחים?
אנחנו הבאנו.
הביאו לארץ.
אנחנו שתלנו.
עדיין חזק סרט.
מהמזונס, איך? אתה יודע כמה סוגים יותר יוצאים? איך הם חיים ביחד? כולם רוצים אותו.
יחסי גומלין, יש דחייה ומשיכה.
זה לא.
לא? אוקיי.
אז
זה היה
מה התשובה?
אין איזה שעה.
מה זה אומר?
אין איזה תשובה?
אף אחד לא
איך אתה עושה את זה? פיזיקלי?
אני מספר מודל. היו היה, היו בו 20% מהעצים, 100 עצים שהיו מספר רבות. 20 מהם צהובים, כל השאר ירוקים. אוקיי? אני מספר לך שהעצים הירוקים עושים זרע אחד פולט. שני זרעים פולט, אוקיי? העצים הצהובים בחורף עושים על זרע אחד, בקיץ עושים 30. מי יוצא? או יותר חשוב מזה? כמה זמן ייקח עד שאחד יקחי את השני.
למה יכחיד? הם לא יכולים לחיות.
לא, יש לך מצב בולע.
זהו, אבל הם משתמשים באותם משאבים, אתה מבין?
יש לך עולה חקלאי, יש לך בהתחלה 20%, 80%, 30%, זה נע, עד שאתה מגיע למצב בולע, יש לך מצב בולע, ברגע שהמץ הירוק האחרון מת, אין לך עצמי ירוק.
אין משהו שיצא
יש לך מצב בולע, עולה חקלאי, לא משנה מה מיורו שאתה נותן לו, מה המוצר ההתחלתי, הוא יגיע בסוף לאחד מהמקומות הבולעים. כמה זמן זה ייקח? אני רוצה שזה ייקח מיליארדי שנים כדי להסביר את העולם.
זה מה שנדב שלהם כרגע.
אני לא ציפיתי שהוא יחזור. נכון שהוא פילוסופי, ראיתי את זה בפייסבוק.
שבת שלום.
היה טוב.
זה כיתה בפיזיקה שלנו בפילוסופיה. שאיך זה פיזיקה כי זה מדע היקום, אחי.
אחי, כנס לפייסבוק של נדב אחי, תסתכל מה הוא...
וואי, הגענו מהר.
הייתי בטוח שנפתיק, אבל
כן, ראיתם את זה? ועוד הגענו ראשונים.
איכשהו יצא טוב.
וואי, שתדע לך, שמה שאמרת לי שבוע שעבר על האף, מה זה שרט לי את החיים? והלכתי ושאלתי כל בן אדם שני, כאילו,
ומה הם אמרו לך?
שאתה טועה.
אני בדרך כלל לא טועה, זה כל זה.
היה מפגש משפחתי, אני אומרת לך, שאלתי, הסתכלתי על האף של כל המשפחה שלי, אין לי אף כמו של אף אחד.
יכול להיות שלהם גם יפעילו את זה.
להם יש.
אולי לא.
ואפילו חברה מהעבודה אמרה לי שפעם ראשונה שהיא פגשה אותי, חשבה שעשיתי ניתוח אף. מרוב שהוא נראה טוב.
להגדיל אף.
לא, ברצייה.
את רצית להגדיל את האף שלך?
לא. היא אמרה, שעשיתי נראה טוב.
בסדר, זה לא... אני לא חושב שחברות שלך משקרות לך.
יואי, אני אגיד לך משהו.
מה?
אני אגיד לך משהו.
בהצלחה.
אשתי מושלמית. למה אתה מוריד את זה?
למה שאני לא אעשה את זה?
למה אנחנו צריכים מצגת? סרט? בולי?
לא נראה לי.
מה הוא אמר לך לעשות שאתה עושה את זה?
הוא לא אמר לי. אני סתם עושה את זה.
שטויות?
כן. מה אני עושה? מה מושגת עדיין? אני אתן לזה קציתי שהוא ישחרר. לא הבנתי איך שותים את זה.
תיקנת. תקלה.
תיקנתי חלק, קודם. אבל זה עדיין לא עובד.
וואי,
זה
איזה
תקלה.
מה.
הוא עבד?
כן. מתישהו.
לא, בשביל שהוא ימות צריך קודם כל לחיות.
בואי נתקדם שוב. Say that we won't change your name. Always be nice. I'm gonna hold you forever. That we would ever change your mind. Stay with you. Always be nice.
כן, תמיד קול, קול, קול.
איפה הפרנש? כן. אוהבת שלו. ניצן, נרשמת יש חוג זמרה של בר אילן, שתדעי.
איך קראת לי?
ניצן. כן,
מה זה חוג זמרה?
יש חוג זמרה בבר אילן.
אני מאוד מקווה שזה לא בקטע ציני ורע,
כן,
ודווקא בקטע
את
מעריך
יודעת
על איך
לא, באמת,
ששרתי.
יש גם הרכב באוניברסיטה.
לא, ואני אומרת בקטע מעריך על איך ששרתי, ולא על
לא,
בקטע
מה
מעליב על איך ששרתי.
אם אני הייתי אומר את זה, אז
זהו,
את יודעת
בגלל
מה
זה אני.
התשובה. אבל זה אם זה לא אני.
רגע, איפה אתה? הבאת אותה כבר?
כן, הבאת לי בשבוע שעבר.
סבבה. יש מישהו שאני חייב לו? אני לא יודע.
אם לא הוספנו לאף אחד.